Hi guys, today we're going to learn about families of polynomial functions, which is in Unit 2, Lesson 2.4. What are they? A family of polynomial functions is a set of functions that have the same or similar characteristics. Functions that have the same x-intercepts are also said to belong in the same family since they have the same zeros. The variable k is often used and may be the leading coefficient in some equations, which allows you to stretch and compress your graph as long as k is an all real number. Example 1 explains on how all four of these equations belong in the same family. Our first equation, which is f of x equals negative 3, x plus 1, x minus 4, x minus 2. Then we have our second equation, f of x equals 2, x minus 4, x plus 1, x minus 2. Our third equation, f of x equals negative 1, x minus 2, x minus 4, x plus 1. And we have our fourth equation, f of x equals 5, x plus 1, x minus 2, x minus 4. They are similar because they belong to the same family as the zeros are x equals negative 1, x equals 2, and x equals 4. But they are also different because the leading coefficients of each of them are different values and they have different signs, leading to a difference in shape and direction when graphing. How do we find the equation when we're given a graph? Our first step is stating our x-intercepts, which in this case we have negative 3, negative 1 over 2, 1 or 2. Then our second step is putting the zeros as factors into the equation, which I put y equals k bracket x plus 3 bracket 2x plus 1 bracket x minus 1 bracket x minus 2. Our third step is pick a point in the graph. I chose negative 2 and 18, negative 18. Our fourth step is substituting that into our equation, which I did. By doing that, I got my k value as negative 3 over 2. And then our final step is just plugging our k value into our original equation to get our equation, which will be y equals negative 3 over 2, x plus 3, 2x plus 1, x minus 1, x minus 2. Example 3. Determining the equation using a given point. Let's determine the equation of a function that passes through the point 1 over 1 and 4. Let's say our zeros of a graph are 2 and negative 3. So our equation would be f of x equals k bracket x minus 2 bracket x plus 3. We plug in 1 and 4 as our x and y values, 1 being our x, 4 being our y value, so 4 equals k bracket 1 minus 2 bracket 1 plus 3. Then we bring it down, 4 equals negative 4k, we divide both sides by 4, our k value is negative 1. We just plug in our k value at the end into the original equation, which gives us f of x equals negative 1, x minus 2 bracket x plus 3. How are they used in real life? Families of polynomial functions, they're used in many fields, from being used to determine the shapes of structures in engineering to helping predict local population growth every year, and it can also be used efficiently to optimize profit and cost in economic sectors. That's the end of my presentation.